Hi everyone, welcome to this month's community call. And because the last time we've seen each other was in December, I want to wish you all a happy new year and all the best in this year. So let's look at the agenda of today's call. So first we'll have an update from our side as usual. Alexis will talk about the new server RFC process that we've introduced, and that will be interesting for you as well to see what features we're currently working on. Then KP will introduce some new CLI features that he's been working on, which will be followed by an actions demo where Rishi will do a demo and showing use cases for actions. And finally, we'll have a mystery demo by Tanmai, so I think this will be really exciting too. And finally, we'll have a community demo. I love community demos, so it's really cool to have Gavin Ray speaking about setting up and deploying a full Hasura Kubernetes stack. So also very much looking forward to this. So I think with this, we can get started. Alexis, if you're ready, I will stop sharing my screen.
All right, so let's see. So as you can probably infer from the title here, I'm going to talk a little bit about an RFC process that we've been working on. But before I talk about what the process is, I want to talk just very briefly about why we're creating the process in the first place. So as I'm sure everybody on this call is well aware, GraphQL engine is mostly open source, which is great. And one of the reasons that's really nice is we get a lot of community contributions in the form of pull requests, and most of those are for documentation, which makes sense given that documentation is both sort of the most accessible thing to contribute to, and also one of the things that is it's hardest for us to sometimes know what the right thing to document is, since we work on it all the time and we sort of know too much. But even if you kind of ignore the documentation changes, we also get a lot of nice pull requests for things like the console and the CLI. But sort of conspicuously absent from this is information or pull requests contributing to the server, which is not shocking because, I mean, for one, there's just not that many people who know Haskell relative to people who know JavaScript and Go. Also, we're sort of lacking in terms of information to help people contribute to the Haskell code, and we are working to improve that. But even if you ignore both those things, I think it's not super surprising because the server is complicated. It does a lot of complicated things. And it's very different from, I think, a lot of the things that people work on in their day-to-day. And so I think it's not super surprising that people are sort of intimidated when it comes to actually trying to make changes to the server. So for that reason, we're kind of trying to put together an RFC process that makes it a little bit easier for people from the community to contribute and have some influence over the process and have some say over the process without necessarily having to actually get their hands dirty and write Haskell. So there's sort of two broad reasons for this. The first one is that if we're going to make changes and we have changes that we plan to implement that are large and complicated and we don't just want to sort of jump in and work on them, then we would like to be able to collect feedback from people before we sort of decide what it is that we're going to implement. And the second is that if somebody does have some feature that they have a suggestion for, then currently it's sometimes kind of difficult. Like, obviously we try to implement things that, you know, people demonstrate that they want, but sometimes it's hard to know exactly what that is. Sometimes we have an issue and a bunch of people say, yeah, you know, I would really like this to be implemented. But then we actually kind of get into it and we realize, one, we're not entirely sure exactly what that is. And maybe some people in that issue thread, they all have like a slightly different idea of what the thing that they want implemented is. And that can be very difficult. So by providing just a little bit more structure, hopefully it should make it a little bit more likely that if someone has something that they're really passionate about, that we can figure out how to turn that into something that actually gets implemented. So with that in mind, I want to talk a little bit about what the process is. So it's not that complicated. If you're interested in participating in it, it's pretty easy to do. The first one is that you kind of, if you want to submit a proposal, then you write an RFC document. Now that sounds a little bit intimidating, but it's really not that bad. Basically, an RFC document just needs to contain a high-level description of what the change that you want to make is, some motivation for why you want it, and sort of descriptions of alternatives and why you don't think that they're viable and why this is a good solution, and also some hopefully fairly precise specification of the change that actually should be made. And this is kind of one of the major differences between just sort of the existing issues that we have. But crucially, this is not necessarily in a precise implementation plan, because that would sort of defeat the whole purpose. So it doesn't necessarily have to be something that says, we're going to make this change to this module of the Haskell code. Obviously, if that's something you can provide, that's great. And as we're sort of submitting our own RFCs, we probably will include information about that just because we're familiar with the server code. But really what I mean by that is more, if you are submitting an RFC, it should say, I'm going to add this API, and this is what a payload should look like, or maybe this is the SQL that should get generated, but it doesn't have to go into the details about how the server actually implements those changes. So then once either you or somebody else has submitted a proposal, then there's sort of the longest phase of the RFC process, which is the discussion and revision process. So this is just sort of what you would expect. People can weigh in about what they think is good or isn't maybe so good about the proposal, and they can ask questions and get clarification. And at this point, sort of the person who's submitting the proposal, it's sort of expected that it's their responsibility to actually respond to these questions, update the proposal in response to any feedback that people have. And eventually it'll sort of go through a few different rounds of revision. And then hopefully, eventually, if after that process, everybody feels reasonably good about it and it's in a good spot, then ideally we'll accept the proposal and maybe implement it. So the idea is that once we get to the point where we can accept RFCs, we'll merge them into the main repository. We're going to create sort of a RFCs directory in the main repository. And once an RFC gets merged, it should be ready to be implemented. So basically, implementation details, like I sort of said earlier, don't need to be worked out, but the ideal is to figure out all the behavioral specifications during the RFC discussion process. So once someone goes and starts implementing an RFC, ideally we shouldn't have people wondering, wait, actually, what is it supposed to do in this particular case? That's something that we would like to be able to work out ahead of time. It's not always possible, but it's what we'd like to aim for. And importantly, as a caveat to all this, accepting an RFC does not necessarily mean that we will dedicate time immediately to personally implement it. I think part of, obviously, if it's something that lots of people say, this is something that we really want, then of course we'll prioritize working on it. But I also just don't think that that should be something that gates accepting an RFC. If an RFC is good and somebody specifically has sort of put it forward and said, I'm interested in implementing this, then that's also something that we're happy to accept the RFC and help people implement it. And hopefully this will be sort of one part of making the server a little bit easier to contribute to for people who are interested in doing that, to provide just a little bit more guidance. So that's about it for the RFC process from a high level. There's a few things that we still need to kind of work out about how we want to manage this and things that we need to do. So one of the big questions is, how can we most effectively get the RFCs in front of the right people who are sort of qualified to comment on it and have useful comments that we can actually, to provide actual useful feedback on these RFCs. And I think some of this is probably always going to fall upon the person submitting the RFC to submit the proposal into the relevant places, but we can also probably do a little bit of work to post RFCs on Discord or contact relevant people, things like that. This is still something we're just kind of getting started, but definitely once we've been through this process a few times ourselves, we'll put a template somewhere of what an RFC looks like to make it easier for people who are interested in submitting their own RFCs, if they are interested. And also we'll put all the information that I've talked about here, as well as some additional details in the repository somewhere. So that's really about it. If anybody has questions or comments right now, I'm happy to answer them. Otherwise, if people have questions or comments, happy to talk about those on Discord or GitHub or anywhere else.
Thank you, Alexis. Does anyone have questions for Alexis? If not, then we'll move on to KP.
Yeah. So I think I'm audible, right?
Yes.
Yeah. So now I'll just try to share my screen. And I hope it's visible.
Yes, it is.
Yeah. So on the CLI side, like we have been like working on a bunch of things which has come up from the community itself in the form of GitHub issues, Discord messages, etc. So of that, one of them is like a go-to flag kind of thing. So to explain the context, let me just go about the issue. Like let's say we have a migration status like this. We have a bunch of migrations, and we are at here. It's at the second last stage. It's 052, and let's say we have to go back to, let's say, 002, and so the documentation of version flag is a bit vague. So what a user will probably do is like use the version flag and go to that particular, and will try to go to that particular version. So the problem here is that the output of the command will not be as expected. So we'll expect something like this. So we have to go back to the 002 version, and we'll expect an output like this. But what happens is the output will be like this. So even though the version flag was intended to do this thing only, but the documentation is a bit vague. So we have a lot of discussion going on here, and what we went about doing is like introducing a go-to flag, which will exactly solve the problem that we have. So I'll like try to demonstrate that a bit. So I'll go to my terminal. So I have alias h as Hasura, like Hasura status. So right now, this is what our state is. So as I said, I have alias Hasura's h. So h migrate, and we'll like try to do all the up migrations. Okay. So we'll like apply, and we will apply all the up migrations. So which will provide us a state like this. So as in the issue, like let's say we want to go to this particular version, that is 008. So with the new go to command, what we will do is like h, like means Hasura migrate, apply, go to that particular version. Typo, go to, yep, and which will give us the expected output. So this is what we done in the go-to flag side, and something else that we have been working on is like you know, and by the way, we have this PR 3715, which is implementing the go-to flag. And if folks have some like suggestions or something like that, just feel free to put it here. And apart from GoTo, something else we have been working on is like an interface to add seed data using Hasura. So, and there is a RFC, for that exactly. And we had some discussions here, and folks, please feel free to add your suggestions and thoughts on this as well, so that we can make it according to what the community thinks. So yeah, I think that's it from the CLI side. Marion, you can maybe take over.
Okay, thank you, KP. Are there questions about the CLI features? By the way, you can also always ask questions in the chat, and then somebody will answer even during a presentation. Otherwise, we'll move on to Rishi for the actions demo. Rishi, are you ready?
Hey, yeah, just a second. You all can hear me?
Yes.
Okay, I'm gonna share my screen quickly. You all can see my screen, right?
Yes, we can.
Okay, so my name is Rishi, and we've been working on actions lately, a pretty exciting feature that most of you know about. For people who don't, I'll briefly introduce. So actions are a way to add custom business logic to Hasura. How actions work is you define the mutation definition of an action, and you define an external webhook. And whenever that mutation is made, Hasura contacts the external webhook and where external business logic can be performed, and then returns the response back to the client. Right. So let me start with a tiny example. let's write a tiny mutation, totally unrelated to the database. I'll just call it add, which takes numbers as arguments, which are an array of integers, and it returns add result, which is a new type that I will define here. Type add result. It just has a field called sum, which is an integer. And handler, this is the URL for the webhook, where we will perform our business logic. We'll come back to this in a bit. And the kind means action can be either synchronous or asynchronous. In case of synchronous actions, when the client tries to make the mutation to Hasura, Hasura contacts the external webhook and immediately gets back the response and sends it to the client. But in case of asynchronous actions, Hasura makes the request to the webhook. The webhook might take some time to process it. So Hasura ID, the client can subscribe to that action ID to get the response of that particular action. So in this demo, we'll just look at synchronous actions, and so I'm just going to create it now. So the action is created. You can modify it. You can create relationships from actions fields to the tables in Postgres. You can also set permissions, and we also have an FT feature called code gen. So we generate code, the webhook handler code for you. So currently we have Node.js Express, Node.js Zite, and TypeScript Zite. If you see here, this is the code for Node.js Zite. This is for TypeScript Zite. In case of TypeScript, if you see, we have also generated the types that you can use. Well, so let's go with Node.js Express for now, so that I can quickly show the demo. So I will try to deploy this handler to glitch. That's the quickest for now. Well, so this is the glitch project. This is the server. Just paste it here. The handler code, I'll call it add handler. As you see in the code, first you get the input from the request payload, then you perform some business logic. Our business logic is just to add those numbers. So let's say sum 0, numbers dot for each. Yeah. And here I just return sum. Loading, yeah. I will just get the URL of this server, which is this. Also, I have to add an extra route here, post route. We call it add, and the handler would be add handler, which is this, right? And then I go back to my action, and I change my handler to this /add. I'll save. So now if I go back, in this to add numbers is 1, 2, 3, 4, and return sum. So it's going to return me the sum. I do this, and it's going to give me the right sum. So that is one use case to do to perform custom business logic unrelated to the database. The second use case is to validate the Hasura mutations. So let's try something. I already have a user in the data. I already have a table called user in the database, and it has 2 entries right now. So I'll try to change my email address. So I'll go to graphical. I'll say update user by PK, set email and ID, and I'll ask for age, email, ID, and name. Let's remove this ad. This ID will come from a query variable, and so will this email. We'll define the query variables. ID is an integer, and email is a string. Sorry. And I will give the query variables as ID is 1, and email is Rishi +1 at hasura.io. I try to make this mutation. It works. Now I'll make it 2. I'll make it 2. It works. So, but now, if I do this, this is not a valid email, but still it works. So let's try to add custom validation to this mutation. To do that, I'll just wrap this mutation with an action.
Name the mutation, set email.
Oh, right. Yeah, I'll call it set email, and I just derive it. So based on the types of that mutation, some action definition with the appropriate types were templated here, and you can directly create and just like add the similar this webhook URL, and I'll just call the route set email, and that's it. I'll create. Now to implement the logic, as you see, since this is a derived mutation, derived from a particular Hasura mutation, the code for delegating to the parent mutation is also generated by Hasura. And in the handler, as we see, we first get the request input from the payload, then we run some business logic, and then we delegate the same mutation to Hasura. In this business logic, we can throw some errors if we want to. And if Hasura returns an error, we will return an error. If Hasura returns a success, we will return a success. Right? So I'm just going to copy this. And I'll just go paste here. I'll call it set email handler. And I'll add another route, app.post / set email handler. Yeah, hope there's no typo here. Yeah, works. So I'll just go back now, and I will try to make a fresh mutation to the set email action. So I'll just say ID is 10, I'll ask for age email 1. So I'll say ID is 1 and email again Rishi 123 for something, not a valid email. Right? We'll just remove these variables. And when I try to run this, it will still work because currently we have just wrapped the Hasura mutation. Now let's add custom logic to it. So you go back to your handler and just run if email.match, copy the email regex, return res.status 400.json message invalid email, and it is built. I'll go and try it out now. It threw me an error saying invalid email. Now I just make it a valid email. Hope this is a valid email. This is okay, sorry. And I just send it and it has been updated. I'm going to set it back to my real email for my satisfaction. Hasura.io, and here we go. So that's about it for the actions demo. It'll be out soon. Even we have our fingers crossed. Excited to see your feedback. Also, one more thing apart from actions is you must have seen, I did not cover, we also have these food notations now. There is just like we had select by user, select by PK in queries. Now in mutations we have, oh my god, okay, yeah. Now in mutations we have delete user by PK, update user by PK, and insert user 1. So you can insert a single user, you can update a user by its primary key, and you can delete the user by its primary as it was shown in the demo. But that's it from my side. You can ask me questions if you have any, and I'll be there in the comments to reply to them. Bye.
Thank you so much, Rishi. So I think questions are getting answered in the chat. This is fine. And then I think it's time for Tanmai's mystery demo.
All right. The ultimate mystery was that Thiru was going to be doing the mystery demo, but I did the mystery demo, or I am going to be doing the mystery demo. I'm going to talk a little bit about some new stuff that we've been doing on the CLI. primarily to a kind of a new migrations and metadata workflow. And so I'm just going to start sharing my screen to kind of go over that. Let me do just a second. I have a multiple desktop situation that I'm going to fix first. All right. Cool. All right. So I have a console here, and in my console, I have a few actions and some data tab and some relationships and tables and stuff like that. What I can do now is, and this is kind of what a Hasura project directory or the project directory structure looks like, right? So there's a config.yaml, there's a migrations, and every time I use the console to kind of do things, and especially if I'm using the Hasura console, the CLI console, then migrations and metadata kind of get automatically tracked, right? What I have right now inside the migrations directory is a single migration, and this has kind of like an up.yaml and a down.yaml and stuff like that. What we can do, and the kind of way to upgrade to the new directory structure is I have the new CLI which I've aliased to Hasura dev, and so I'm just going to run. We've kind of added a scripts command to make it easy to have these kind of code mods and stuff like that. So I'll do a Hasura dev scripts and update the configuration to v2. As soon as I do that, you'll see that a new metadata directory has popped up. So let me just run a git status. So you'll see that the config.yaml is modified because this is kind of like the V2 of the configuration. This is all backwards compatible, and changing into this is optional but recommended. So don't worry about anything breaking. If you look at the config.yaml change, I'll just cap that out. There's a version 2 that's been added there. And there's a explicit metadata directory and an explicit migrations directory now. And if we look at what the metadata directory has, it has these kind of different files. So we've split metadata.yaml into individual YAML files, just to kind of make it easier to stick into version control, do code reviews on. We've cleaned up the metadata structure as well a little bit, especially to remove kind of like a lot of the empty relationships, empty permissions kind of craft. And this plays especially well with actions because you can just kind of write the GraphQL directly into a file as well. And so, for example, if I open up the actions.graphql file, you'll see that I can just type in actions here, I can edit them, and that can just be my usual GraphQL code writing workflow, right? What we can, to kind of show you an example of how this works with the CLI console, I'm going to do, I'm just going to quickly commit this first. Let me just git add metadata, git commit -a, moves to v2. All right. Let me now open up the console, the CLI console. And so let's say, for example, I create a new table here, a test table, add in an ID and a name, text, and hit save. Right. What you would expect to happen in the older project directory structure is that a new migration file would get added. And so if I hit a git status, you'll see that there's a new migration file that's been added. And if you look at what the contents of those migration file, of what this migration file is, let me just, and it has an up.sql and down.sql. And if I cat that out, you just have the raw SQL. So the other kind of desire also is to move from having SQL inside YAML files, which was a little bit disgusting to look at, and it's nicer to have raw SQL so that you can again just use editors, have code highlighting and stuff like that. So there's an up.sql and down.sql that will be generated, and then of course we can just do a git diff on the metadata tables.yaml, and we'll see that this table has been added to the metadata. So this is now a tracked table, right? And so what I can do again is kind of just add this to my migrations, track this and say whatever, add table test, right? And then if I go in and kind of make new changes, right? So let me go ahead and make another change. Let's say, for example, I untrack this table. And I go in, or let's say I want to untrack this table now from code and not from the console. What I can do is I can kind of switch back to directly the metadata file here, open up tables.yaml, And then this is now kind of much easier to just manipulate directly because this kind of like a simplified file. So I can just remove the test stuff here, right? And then just hit a metadata apply. So Hasura dev, metadata apply. And then as soon as I do that, what I'll see is that the kind of test table has disappeared from here and now is an untracked table, right? So basically kind of separating out Hasura metadata from the migrations makes it a little bit easier to kind of deal with the SQL migrations and more complex SQL workflows easily and keeps the YAML file and keeps the YAML files, also splits them out so that they're easier to kind of grok, they're easier to review. Stuff like that. There is a small caveat though, which is that the niceness of having the like being able to kind of roll back to a particular point of time where the SQL and the Hasura metadata were in sync has now become harder. So that's kind of the caveat here, right? The metadata no longer is something that is incrementally tracked. The metadata is kind of like the latest point in time tracked, and the migrations are incrementally tracked. So that means that if you're kind of going back or rolling back to an older version of the migration, the right way to kind of roll back to that right version of Hasura metadata would be to kind of git checkout to an older point of time, and then kind of do a Hasura metadata apply to bring in the metadata from that point of time, right? So that's kind of the caveat here. But overall, this should be an improvement to the workflow generally because metadata and migrations will now be separately managed, and it just make life fairly convenient for a bunch of complex things, right? Especially if you just want to kind of dive into the code directly. You want to copy the same permissions in a bunch of places. You want to edit the GraphQL file directly. You have the same permissions that you have across. I don't have a permission defined, but suppose I had a permission defined and I wanted that same permission to be across a bunch of tables. It's just much easier now to deal with that in code. Maybe have a Vim macro or something, right? Whatever kind of workflow you're used to. So that's kind of the change that we're bringing in with this. And obviously this will work really well with the actions workflow on the CLI as well. Exactly what Rishi showed to you via the console. You can do pretty much the exact same thing via the CLI as well. So you can do a Hasura dev, actions create, and then you can derive from, and then you can kind of paste in the mutation, the example that Rishi was showing to you on the console. That exact same workflow will be available on the CLI as well. And it'll be a little more powerful because you'll be able to edit the actions.graphql file and the YAML files directly, without having to kind of go to the console UI. You can always switch back and forth between the console and the code thing, but you don't have to use only the console or only the CI. So yep, that's the demo for the kind of new and improved metadata migration stuff. This will be a config v2, and so nothing will break, and we'll be rolling this out sometime next week as well, along with actions. That's pretty much it. If there are any questions, feel free to ask questions.
Thank you, Tanmai. So feel free to continue asking questions about this mystery demo. Yes, so now it's time for our community demo. So Gavin, if you're ready, you can go.
All right, share desktop. Okay, can you guys see everything?
Yes.
Okay, so there's a couple things I'm going to cover. First, before I forget, I wanted to touch on what Alexis mentioned at the beginning with the RFC. And this is something I've talked to Marion about privately, and I put it in the public chat. But there's a service called Gitpod, and they're free for open source projects, and it lets people launch an in-browser IDE that has all the project dependencies configured. And I reached out to the people at Typefox who create this, and they they offered to provide us support if we needed, because Marion said you guys kind of didn't have the bandwidth at the moment to set this up. But I think that this would be like a really huge bonus for getting people engaged and hands on the code. The other thing is that the K8 setup that I'm going to be doing today, it's kind of all put together by this tool Garden. The founder and CEO, John Edvold, another dev, thank you CTO, like Emmanuel, they're here supporting, so they will be able to correct me if I make any heinous mistakes and answer questions. So yeah, the first thing that I want to do is demo the seeds functionality that I merged into the CLI. So I recorded this just because like the more people that watch you do something, you have a proportionally higher chance of messing up. So it was less stress. So this is just a run through of creating and using seed files from the Hasura CLI. So the first thing that I'm going to do is print out the documentation for it. And then I'm going to show that I have no seed files. And then you can see here that I have a couple records in my Hasura instance. And the next thing that we're going to do is we're going to dump those tables to seed files. And then now I have seed files, and if I check those out, you can see it is just SQL insert statements for those tables. So I'm going to delete those records in my Hasura instance. And then now I'm going to recreate them with the seeds. So there they are. That's pretty much that. The semantics are basically the same as the migration command. So I took a lot of the functionality from there, but what's left on that to do is just get approval from Shahid. I think he wanted to change like the ergonomics of the CLI commands a bit. So the next thing I'm going to do is I'm going to show you how to set up a full K8 stack using Garden. And Garden is kind of similar to Docker Compose, but it lets you do it on like Kubernetes. The cool thing about Garden though is that it was primarily created as a tool for like remote K8s development. So the point is that you can have no dependencies on your local machine, and you can sync it against a remote Kubernetes cluster, and it'll set up like proxies and port forwards and like an ingress point, so that anybody on your team can start developing services on Kubernetes from your stack without having to do a whole local setup. In our case, we've chosen to use micro K8s. So basically the way it works is that you have a top level garden.yaml, which kind of configures your entire project. And then for each service, you have a garden.yaml, and that basically describes what type it is. So for example, this one is a Docker container. One of the cool things you can do with Garden too is that you can inject templated variables. So my view front end, if it's remote, I'm going to use a dockerfile.prod, which compiles it to it's like an Nginx server. Otherwise, I'm going to run the dev Docker file, which is just like an npm run serve. You set up like local ingress points. So like here, I'm going to expose this service as like mocks.local.app.garden. Hasura, it supports health checks. You can configure your environment variables, yada, yada, yada. So here I have K9s, and you see that these are the services that I have. And what I'm going to do is I'm going to run a Garden dev locally. All right, so now we're deploying Hasura, Postgres, my Vue front end, the Node.js API, and my mock server. This is going to fail because Hasura is still like running its migrations, and it has to wait for the health check to pass. Okay, there we go. Okay, let's check it out. So this is really cool. Garden will give you a stat graph of your service dependencies. So using like which services depend on what, it'll figure out what order they need to be built and deployed in. And you can also do things like tasks. So for example, like a DB init to create tables. You can do migrations. It also integrates with tests. So you can run like your entire test suite on save. And then if you check it out here, so I have Hasura running. I have a Vue front end. I have this Node API. And I have an Apollo mock server. This is really cool. I'll release this later. It automatically generates mock data using Faker.js from introspecting the schema of your Hasura instance. So this way you can start testing without having to have a bunch of seed data. But yeah, so for demo purposes, let's collapse these services, front end, SRC. Let's open app.vue. All right. Okay, so here I'm making a query and to Hasura, and I'm trying to get to-do ID and text, and then I'm just using a v4. So what I'll do is I'll come into Hasura. I'll go to data. I will create table to do with ID and text. Type text. Let's add the table. And then I will insert row, make something awesome, save it. Then if I open my, my front end, you can see here that it's hitting my Hasura instance. If I go back and I insert another to do, then there it is. So it also has full hot reloading. So if I make this, if I say like new to-dos and I save this, you'll see that it's gonna rebuild the service here automatically, and it will redeploy it. And again, this could be synced to a remote Kubernetes. For example, I have this also set up to our GKE cluster. And so then if I close this and I open it again, it's new to-dos. Also, you don't have to like use these from here. You can just open them as a regular URL. So yeah, that's really cool. When you want to deploy, then you can just run Garden deploy, I believe. Yeah, so you can just run it to like your staging, whatever environment. And yeah, that is about all I have. I'm sure, I don't know if John or Emmanuel or anybody else from the dev team from Garden that I'm forgetting wants to comment. But yeah, it's super cool. It's free, it's open source. The TypeScript code is some of the best I've seen. It's really crazy. They even wrote their own like parser generator and like, what do you call it? Like a grammar for parsing certain config files. But yeah. Yeah. They're on the Kubernetes Slack under the Garden channel. They're on Garden.io, and then they have their GitHub. So definitely check them out. Star them if you guys want like a really awesome Kubernetes workflow for you and your team. All right. Stop sharing. Stop share. All right, I'm cool.
Thank you so much, Gavin. And thank you for all your contributions and also for demoing this on our community call. So let me share my screen again. So I want to say thank you to all the people who presented from our team, and also again to Gavin for the great community demo. And As always, we want to make our community call better. So if you have 5 minutes, we would be really happy if you could go to bit.ly/community call feedback and give us feedback about this call. And also please let us know what you would like to see in the next few calls, because we take this feedback and then we will do the next few community calls according to this feedback. Also, if you build something cool with Hasura, which I'm sure you have, or if you made a contribution, maybe you added a feature or something else, then please fill in the form at bit.ly/community call demo if you would like to demo this as well in our community call. Otherwise, I want to say thank you so much for joining us today. We'll have the next call on the 26th of February. And you can register on this URL, and otherwise we will publish again on Twitter and also on Discord for the next community call. Thank you so much for joining. Bye.